The next thing to look at is significant variables. So look at that specific line again, at which the error is occurring. And here's what I mean by significant variables. There are only some variables that can be causing the exception. Now, which variables these are depends largely on the exception. I'm going to show you, or I'm going to go through the three types of code statements you might have in your program and which variables are significant to all exceptions. But of course, depending on the exception, there might be less that are significant. However, I'm also going to be looking largely at the null pointer exception, or in other words, let's say you put in a variable here like variable 3, and it was supposed to have a value, but it wasn't defined yet, or it wasn't instantiated yet, and it holds the value of null, or it holds the value of none if you're using Python. And that might be, those are, from my experience, I've noticed that those are the most common exceptions that I run into when I'm programming. So those are the ones I want to focus on mostly. But similar sort of thing applies to any exception. The first kind of statement you have would be a statement like this, where you're assigning a value to a variable. Now, in this instance, variable 1, there can't be anything wrong with the variable 1 that is causing the exception to be thrown. That's because you're assigning a value to the variable. So you're not actually looking at the variable itself, you're just modifying the variable. Now, of course, you could have a problem like variable 1 is constant, but that's no longer a runtime error, that's a syntax error. However, variable 2 and variable 3, in both of these examples, they could be null, or there could be something wrong with that value to the point that it can't be assigned to variable 1. So in this case, your significant variables are variable 2 and 3 in both of these lines. Now, the next type of code statement you might have is a function call. And when you call a function, it depends. You might have a reference to an object here and use that to call a function within that object, or you might call a function within the current object that you're working in, or the current class that you're working in, and that's the lower example here. But in that case, let's say variable 1 here is null. Well then, of course you can't call a function of null or none, so that could be causing the error. Let's say variable 2 is null or none, and the function is not supposed to take in a null value. That could be causing the error. Same with variable 3. So in this case, in this instance, if you have a code statement like this, all of these are considered significant variables, and all of these are variables you'll have to take into consideration because they could be causing the error. Now, the third type of code statement you might run into is what I like to call the conditional block. I'm not sure if that's the proper terminology for it, but in any case, for example, if you have conditional and if-else conditional, and within here you have the actual condition itself, and if variable 1 doesn't exist, or variable 2 doesn't exist, and by doesn't exist I mean hasn't been defined yet, is null, or let's say has some sort of bad value that it can't be compared using this operator, for example, then that could be causing the problem. So in this case, both variable 1 and variable 2 are significant variables. In the while loop, same thing, this variable, maybe it doesn't have value associated with it. That could be causing the problem. Then looking at the for loop, if you program in Python, look at the bottom line. If you program in just about any other language, look at the top line. They're equivalent statements. In this case, if we look at variable 1 is declared here, and it's instantiated here, or initialized here, I guess, to 0. And then we're modifying it here, but of course we know it exists. There are really not going to be any problems with variable 1. So in this case, we don't consider variable 1 to be a significant variable. We don't have to consider it at all. However, variable 2, this could throw an exception if for some reason it has the wrong value or if it's the wrong type of variable. So in summary, once again, if you're assigning a value to a variable, that variable itself that's being assigned the value does not have to be considered. It's not a significant variable. And here, in a for loop specifically, if you have a counter, I'm going to consider this a counter, and you're declaring it here, that you also don't have to consider as a significant variable. However, every other variable that you come across is going to be significant. And by significant, I mean it could be possibly causing the error in your program, and you're going to have to look into it. The next step is to print those significant variables, those variables that could possibly be causing the problem with your program. Now, what I like to do is I like to put print statements, and by print statements I mean system.out.println if you're using Java, or cout or printf if you're using C, or let's see what else, console.log if you're using JavaScript, whatever. I like to print those significant variables right before the line at which the error occurs. And in that way, when I rerun the program, it's going to error in the same spot, but right before it errors, you'll see the values of the printed out variables. And of course, be careful because you'll have to actually convert the variables to a string in order to be able to print them out, or you'll have to print them out in a way that doesn't cause another error, but actually gives you the value of the variable. If, for example, your program throws an exception but continues running for some reason, and you want to look at that exception, another thing you could do is you could manually put an exit statement after you print the variables. You can put the variables before the line at which the program errors, and then an exit statement immediately after printing out after those print statements that print out those variables, and that will force the program to terminate execution right after printing out those variables. And so that's the last thing you'll see on the screen, basically. And once you can determine the values of those variables because you printed them out and you can see them on the screen, then you can determine which variables don't look right, or which values of the variables don't look the way you want them to. And if all of them look right, well then clearly there's a problem with the statement itself at the line at which the error is occurring. And that's the point at which I'd go look into documentation or look at examples online, because maybe you don't know what the statement itself is doing, or maybe you don't know how the library function works. However, more often than not, you're going to notice that one of the variables does not have the right value, or does not have the value that you want it to have. And in that case, you go to step 6, and there are two options. I like to backtrack. You can also run through. Let me state right away that by run through, I don't mean run the program again. I mean run through it in your head. But let me explain each of these. So by backtrack, we take the significant variable, the variable that's causing the error, and in our head, we go back through the program and look, where is the last time that that variable was edited in some way or modified in some way? And where that variable is modified, I like to put a print statement right after or right before it was modified, or sometimes both. And sometimes I can just go back to the last point at which it was modified before the error occurred, print out what it was before it was modified and after, and I'll see that it wasn't modified in the right way, and that's where the error is occurring. And sometimes I'll just have to go back once in order to do that, but other times I'll go back and I'll see, well, the value still looks wrong there even before it's modified. And in that case, I'd have to keep going back or keep backtracking and seeing where that variable was last modified. and keep adding print statements there until I realize, oh, here's where I changed the value to something and it's not what it's supposed to be. Now, I think this will all make sense after you watch me do some examples of this. But your other option is to run through the code in your head going forwards. And when you run through the code, look specifically at each point at which the variable that could be causing the issue is modified. Similarly to backtracking, you're only looking at those significant variables that we talked about earlier. So when you run through your program, look at where it's modified, and you can add print statements, or you can, if you can figure it out in your head, where is it not being modified correctly.